My friends, welcome to another exclusive. Now, before we get started here, I really want to get you to get really comfortable with negative exponents. And really, as long as we get a really great foundation with positive exponents, negative, and fractional, which we'll learn later, you will be so set for calculus this year. Now, let's just try to understand some things here. Now, here's the thing. All right, if I asked you to solve over here 2 times 3 to the third, well, 3 to the third, right? What does that tell you to do? Well, when it's a positive exponent, that tells you you're going to multiply the 3 times. Now, a little confusing because you see 3 here, but let's see 3 squared. Well, this is going to tell you that you need to multiply 3 by itself twice. Okay. Well, what does 3 to the 1 mean? Well, that just means you're multiplying there. You're not multiplying 3 by itself twice. It's just one time. Okay. And you can see that we're losing a 3 as we continue on. Well, what if, I don't know, I'll write, let's say 9 times 3 to the negative 1. Now, what if you see a negative exponent? Okay, and with positives, you're really comfortable. Yeah, 3 squared is 9. 3 times 3 is 9, right? 3 to the 1 is 3. 3 times 3 times 3, all that's just 27. No, is that 9 times 3? 27? Yeah, I think it is. Anyways, I'm bad with multiplying numbers, but don't worry about that. A negative exponent. Well, my friends, I just want you to know that whenever you see a negative exponent, okay, that means you are going to divide, or in other words, put it on the denominator. And you might ask yourself, put what on the denominator? Well, the base, 3. So that means 3 is going to go on the denominator raised to the 1 power. So let me give you an example. Let's say 9 times 3 to the negative 2. Okay, well, we have 9. Well, what does the negative exponent means? That means you're going to divide the 3. You're going to put the 3 on the denominator raised to the 2nd power, so divided by 3 squared. And now there'll be 9 divided by 9, which is 1. Okay, so a negative exponent just means that you're going to divide the base, the 3, by however many the power is. So let's say we had 8 times 2 to the negative 4. Well, that means it's going to be 8 divided by, well, the base is 2. So divide, you're going to put 2 on the denominator raised to the 4th power. And that's all negative exponents mean. All right. Is positive is multiplying on the numerator. Negative means you divide on the denominator by the power in the base. Okay. And you might ask yourself, well, what about 0? All right. Well, anything raised to the 0 power, let's say 3 to the 0, that pretty much means that you're going to get 1. And you might ask yourself, why 1? Well, I want you to just think for a moment. When you have a positive exponent, that means you're going to multiply the 3 by itself twice. When it's a negative exponent, that means you're going to divide. Well, there's no number out here, so we put a placeholder of 1. Okay, 1 divided by 3 squared. Well, what is 3 to the 0? Well, 3 to the 0 is kind of like the common ground, which pretty much means if you have a positive exponent, bigger than 0 means multiply by however many. If you have a negative, that means divide. 3 to the 0 is basically saying that you're going to have a 3 on the numerator and a 3 on the denominator, and that's why you get 1. So what's 4 to the 0? Well, that's going to tell you you have 4 over 4. You have 1 on the top, 1 on the bottom, which is 1. Okay, so again, let's see. 4 to the 1 is 4. 4 to the negative 1, well, that means divide, so 1 over 4. And 4 to the 0 means you have the same thing on top or bottom, which is 1. Okay, hopefully that helps out for you to understand negative exponents and how they work. If that's still confusing to you, you can kind of see if we were to just do what's 2 to the third, we get 8. 2 squared is 4. 2 to the 1 is 2. Okay, we'll do 2 to the 0 and 2 to the negative 1. Well, what do you notice is the pattern as we go up in this direction? Well, we're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And that's why you see, oh, 2 to the 0 is 1 because it just means 2 divided by 2. 2 to the negative 1, we'll divide 1 by 2 and you just get 1/2. Okay, let me just erase so it doesn't confuse you. You get 1/2. Again, because you just there's like an invisible 1 there, and you're going to put the 2 on the denominator. That's what the negative exponent means. So for calculus, how is that going to help out? Well, let's try to look at what if you've got a problem like this. And I ask you, let's say 2 times x to the negative 5. Well, this is going to be 2 divided by the negative exponent means put it on the denominator. Put what? Well, the base, whatever this is right here. It could be a 3, 4x, whatever. So x to the, and then the power, 5th. Okay, let's try 9y to the negative 6. Well, it's going to be 9. You see a negative exponent, that means put the y on the denominator. That's all. And then you have a power of 6. And that's it. X to the negative 4. Okay, well, there's kind of like an invisible 1 in the front. So you can put a 1. 1 divided by negative means put the x on the denominator, raised to the 4th power. And that's all negative exponent means. And in calculus, we're going to basically do that all the time. Or I'm going to give you a problem like this. 3 over x to the x to the 4. I want you to rewrite this so that it's a negative exponent. Well, just kind of going backwards, this is going to be 3 times x to the negative 4. And think about it. Why would that make sense? Well, negative means put the x on the bottom, which is over here, and raise to the 4th power. So let's say I got 9 over y to the positive 6. Well, that's going to be 9 times y to the negative 6. All right. You're just rewriting the problem. Let's say you have 1 over x to the 20. Well, that's going to be 1 times x to the negative 20, or in other words, you could just rewrite it as x to the negative 20, because the 1 multiplied by this is just itself. So hopefully that helps you. Let's go ahead and begin and do some calculus with this and see if oops, that should be a positive 20. My apologies. Good catch there. And then let's see if we can understand and make sense of it a little bit better together.